Welcome mga ka-online class! Hi guys, welcome back to my channel. So for today, um, I will not be the one to teach you. I have invited a guest to teach you, and your teacher is none other than Mr. Alien. I am Mr. Alien, and I'll be the one to teach you for today. I'm an alien. Whoa! Wabba-dabba-dab-dab! I'm an alien. Well, our lesson for today is about Newton's third law of motion. In the previous module, you were able to understand Newton's first and second laws of motion. You get to know about inertia, that a more massive object, which has more inertia, is more difficult to move from rest, slow down, speed up, or change its direction. You also learned about the relationship among force applied, mass of the object, and acceleration produced. Newton's law of motion are three physical laws that together learn the foundation for classical mechanics. They describe the relationship between a body and the forces acting upon it, and its motion in response to those forces. More precisely, the first law defines the force qualitatively. The second law offers a quantitative measure of the force, and the third asserts that a single isolated force does not exist. Most of the motions we come across in our daily life are non-uniform, and the primary cause of changes in motion is force. In this module, you will learn about the effects of force on motion, Newton's third law of motion, the law of interaction, will be presented and applied to real-life situations. Let's explore! In this activity, the law of interaction will be demonstrated. We will use balloon, scotch tape, plastic drinking straw, and string. First thing to do, get a string and tie one end of the string to a chair. Second step, take the balloon, blow up the balloon, and pinch the end of the balloon to keep the air inside, like this. Third step, take the drinking straw and tape it in the balloon using the scotch tape. Fourth step, insert the string through the drinking straw. After doing so, tie the other end of the string to another chair. And lastly, release the balloon. Why did the balloon flew? This because of the air inside the balloon. As we release the air inside the balloon, the air pushed the balloon forward. The more air in the balloon, the faster the balloon will move. The balloon moved because of the law of interaction between the air inside the balloon and the balloon itself. Newton's third law of motion, the law of interaction, in the simplest sense, a force is a push or pull. However, Newton realized that a force is not a thing in itself, but part of a mutual action, an interaction between one thing and another. For example, consider the interaction between a hammer and a nail. A hammer exerts a force on the nail and drives it into a board. But this is not the only force present, for there must also be a force exerted on the hammer to stop it in the process. What exerts this force? The nail does. Newton reasoned that while the hammer exerts a force on the nail exerts a force on the hammer. So, in the interaction between the hammer and the nail, there is a pair of forces, one acting on the nail and the other acting on the hammer. Such observations led Newton to this third law, the law of interaction. Newton's third law of motion, the law of interaction, states, for every action, there is an equal and opposite reaction. If you push hard on a wall by a force of 7 newtons, the wall in turn pushes you back by a force of 7 newtons. So there is equal, but they are opposite in their direction. A weight of 115 newtons means that the earth is pulling down on the object by a force of 115 newtons. In turn, the object is pulling earth by a force of 115 newtons. So again, equal, but their directions are opposite. To put it simple, the third law says that action and reaction force are equal in magnitude, but oppositely directed. Action and reaction force are acting on two different bodies and will never cancel out. Forces always come in pairs. Newton's third law of motion has many applications. You can walk because you push back upon earth as hard as the earth pushes you forward. The same situation applies when rowing a boat. You apply a force propelling the water backwards, and the water provides an equal and opposite force by propelling you forward. Diba? When you row a boat, the water goes to the back, but you move forward. The same. There is an equal force there. The action is when you row the paddle and the water goes to the back of the boat. The reaction force is when the boat moves forward. The force there is the same, equal in magnitude, but their direction is opposite because the water goes to the back, but you goes forward. Another application is friction. Friction refers to the resistance to motion between two materials in contact. If you remembered my previous video, there was when I tried to roll the pencil pen, right? And then it stopped. That's because of friction. It resisted the motion of the pencil pen to roll. It is present whenever two materials in contact are moving or have a tendency to move. Aside from the unevenness or roughness of the surface in contact, researchers have shown that friction arises because of the molecular attraction or the local adhesion between materials, local deformation in the contact region, and fluid viscosity. It is also due to the electrical forces between surface when two objects are in contact. There are types of friction. Friction between solid surface is generally classified as static, kinetic, and rolling. Static friction applies to the case when friction is sufficient to prevent relative motion between surfaces. Kinetic friction is present when there is relative motion between the surface in contact. Static friction and kinetic friction are classified as sliding friction. Rolling friction occurs when one surface rotates as it moves over another surface without sliding nor slipping at the point of or area of contact. The term fluid refers to liquid and gas. So fluid friction or drag force refers to the forces that resist relative motion of an object through a fluid or a fluid to another fluid. Air resistance is an example of fluid friction. There are advantages and disadvantages of friction. Friction is undesirable at times and a necessity in some other time. For example, you are able to walk because of friction. It's desirable. You are able to hold things because of friction. There's no friction, objects would slip in your hands. You will not be able to hold them. Cars will not move without friction. Because of friction, the tire can move on the road. Some toys and matches are powered by friction, di ba? When you light up a match, when you light up a match, you there is a contact between the tip of the match and the pad in your matchbox, and it produces a spark which burns the tip of the match. It's because of friction. On the other hand, the disadvantage of friction is that it increases the work needed to operate machinery because there is contact between the gears. It will cause wear and tear. And also it generates heat. If you try to rub your palms together, you will feel that it becomes warm because of friction. It generated heat between your palm. Use of lubricant, wheels, rollers, or ball bearings reduces friction. That's why we put oil on the on engines. We put oil sa engine para the engine will not overheat. Friction resists motion and acts opposite to the direction of motion. For motion to start, maximum static friction, otherwise known as starting friction, must be overcome, because unless it is overcome, the object will not move. Once motion has begun, kinetic friction replaces static friction. For horizontal motion, if the applied force is just equal to the kinetic friction, the object moves with constant velocity. If the applied force is less than the kinetic friction, the object slows down and eventually stops, just like the Pentel pen. Friction is symbolized by a small letter F. Remember, friction is small letter F. If it's capital F, it's force. If friction resists motion, then friction is force minus friction is equal to mass times acceleration, where F is the applied force, M is mass, and A is acceleration. So if we rearrange for us to get the equation of friction, we transfer force to the other side. And then we get this equation. Friction is equal to the negative product of mass and acceleration plus applied force. Here is a sample mathematical problem. A constant horizontal force of 35 Newton is applied to a 2 kilogram block. The acceleration of the block is 15 meters per second squared. Find the frictional force. So in order to solve this, we must find what is being asked. So what is being asked is friction, and find what is given. So we have the given mass is equal to 2 kilogram, applied force is 35 Newton, acceleration is 15 meters per second squared. Using the equation, let's substitute the given. So we have friction is equal to the product of 2 kilogram times 15 meters per second squared. The answer is 30 newtons. Okay, but don't forget there is a negative sign there, so it becomes negative 30 newton. Then finally we add 35 newton because of MDAS. So we first multiplied the mass and acceleration. Okay, we also multiplied the negative sign with what's inside the parenthesis. So it becomes negative 30 newton. Then lastly, we add 35 newton. So negative 30 plus 35 is 5. So the frictional force is 5 newtons. Okay, so I think we're done. We reached the last part of this lesson. I hope you learned something. I will post another video on more examples about solving friction. So I hope you watch it. And then I think that's it. Thank you for watching. Yeah, I'm an alien, yo. Thank you for watching this video. I hope you learned something. You learned a lot. And please, if you haven't subscribed, please click the subscribe button and also click the notification bell so that you will be notified if there are new videos. I would like to shout out to Kyle Forrest Aburat. So shout out to Kyle. Kyle is also my student in grade 8. So I hope you watch this, Kyle, and you learn something about the third law of motion, which is the law of interaction. So once again, spread the love. Vlogger na si Sir. Bye!